This lesson will show you how to use your knowledge of circles to write equations for ellipses. An ellipse is the mathematical term for an oval. So let's start by just reviewing something you already know about circles. If a circle is centered at HK and has radius r, there's its equation. So I'm going to now write the equation of the unit circle that you see on the graph. Okay, the center for this particular circle is 0, 0, and the radius is 1. So if I plug in 0 and 0 for h and k, I just get x squared plus y squared, and then the radius 1, when I square it, I get 1. Okay, so that should be a review of how to write the equation of a circle. What we're going to do now is look at this ellipse in red, and we're going to write an equation for the ellipse. So the first thing to notice is that the ellipse is the circle transformed. Horizontally, instead of having a radius of 1, you now have to go out 2, so it's twice as wide. And the way we can transform our equation to do that is replace x with x over 2. And then similarly, we're going to look at the vertical stretch. And in this case, instead of having a radius of 1, the ellipse has 1, 2, 3, 4. You got to go 4 units to make it from the center to the top. So that means instead of y, I'm going to replace that with y over 4. Oops, got to make sure to square both of those. And then that's equal to 1. And I can clean that up a little bit. Sometimes we write it like this: x squared over 2 squared plus y squared over 4 squared equals 1. And then sometimes some textbooks would rather see it written like this: x squared over 4 plus y squared over 16 equals 1. The reason you might write it this way is that then these numbers 2 and 4 correspond to, in this case, your horizontal and vertical distances. And in fact, in general, every ellipse has what we call 2 axes, a major axis and a minor axis. The major axis in this particular ellipse, well, that's the vertical one, because it's the longer of the two, and its length is actually 8. It's twice this 4, because you have to go from the center up as well as down. And the minor axis for this ellipse is horizontal, and it's 1, 2, 3, 4 units all the way across. That's the 2 doubled. Okay, so in general, if you have an ellipse that's centered at that's centered at the origin, its equation can be written this way: x squared over a squared plus y squared over b squared equals 1. And this distance right here is going to be a, and this distance right here is going to be b. Okay, let's now think about writing the equation of an ellipse that isn't centered at the origin. Well, in order to write it, it's actually a good idea to first think about that same ellipse centered at the origin. And we will now use what we did on the previous screen to write an equation for the ellipse centered at the origin. Okay, so starting with the unit circle, x squared plus y squared equals 1, you'll notice here that this is 1, 2, 3, 4, 5. So it's been horizontally stretched by 5, so I'm going to write x over 5 squared plus, and then vertically it's been stretched by a factor of 2. So I replace y with y over 2 squared equals 1. And then I could clean that up: x squared over 25 plus y squared over 4 equals 1. Okay, if I now want to translate that ellipse to this one, well, notice that the center is 1, 2, 3, 4, negative 4, and then 1, 2, 3, 4, 5, 5. So the way I change my equation to accommodate that, I replace x with x minus negative 4, or x plus 4. And for the y value, I have to replace y with y minus 5. And so y minus 5 squared over 4 equals 1. Again, when you replace y with y minus 5, that moves everything up 5. When you replace x with x plus 4, that moves everything to the left 4. Okay, and in this example, the major axis is horizontal, and it's twice this 5, so the major axis is 10, and the minor axis in this example is vertical, and it's 2. I'm sorry, it's 4. And same thing here. This has a minor axis of 4, a major axis of 10. Okay. For your homework, write an equation for the 3 ellipses. Numbers 1 and 2 are described, and number 3 is pictured on the graph. It might be useful to have this. In general, if it's centered at HK, then its equation is x minus h squared over a squared plus y minus k squared over b squared equals 1. And a is always going to be this horizontal, and b is going to be this vertical distance. Okay, good luck.